Okay, we have this function. We want a complete table and graph. I've given you the numbers on the table. Okay, sometimes you got to figure out what those numbers ought to be, but for right now, we're just getting our feet wet with linear functions. So, well, I'm going to just do the calculations. Y equals 2x minus 4. So if x is negative 2, y is 2 times negative 2 minus 4. And if you do the arithmetic, which everybody did correctly, I think. Saw a lot of negative eights there. Okay. Then if y equals negative 1, you plug in negative 1. You replace x with negative 1. That gives you 2 times negative 1 minus 4. That's minus 6. Then x is 0, so you replace x with 0. You get 2 times 0 minus 4, which equals negative 4. If x is 1, you replace x by 1. You get 2 times 1 minus 4 equals negative 2. And then replacing x by 2, you get 2 times 2 minus 4 equals 0. So you have points you can plot on the graph. Just to be really explicit then, the points negative 2, negative 8, negative 1, negative 6, 0, negative 4, 1, negative 2, and 2, 0 go on the graph. So here's our graph. We'll put a y-axis here. We'll put an x-axis here. Now, y values have to go down as far as negative 8. So I wouldn't sit here and mark off 10 units this way, 10 units this way, and 10 units this way, and 10 units this way, which is often the way you're taught to do these things, okay? Use a little common sense. The lowest x value you need is negative 8. Now, you might want to extend the graph a little bit beyond that, but x equals, sorry, the lowest y value you need is negative 8. All your y values are between negative 8 and 0. So let's put y equals negative 8. About here. Okay. Then y equals 0 on the x-axis. So we could say this is the line y equals 0. If we want to use equal scales, then y equals negative, well, x equals 8 should go about here. Okay. Now, if x equals 8 here, then where's x equals 2? Well, it's a lot closer to 0. Now, on the y-axis, that's where x equals 0, isn't it? And you want to think about everything I'm doing here. The x-axis is the line where y equals 0, because that's what y is everywhere on the x-axis. The y-axis is the line where x equals 0. Very important to understand that, because people get a long ways into making graphs and never seem to understand what those lines are. Okay, so that's why I kind of emphasize these lines. Okay, well, if x equals 8 here, if I go halfway from 8 to 0, I should get the line x equals 4. And if I go halfway from there to 0, I should get the line x equals 2. Then I can see that an equal distance on the other side of the axis gives me x equals negative 2. So I think it's a good idea. Why did I use x equals 2 and x equals -2? Because those are the least and greatest x values, right? X values for my points are between -2 and 2. So I've got to locate where x equals -2 and where x equals 2. Then I can locate where x equals 1, which is halfway between 2 and 0. Okay, so here's the line x equals 1. And here's the line x equals -1. Now my label for the y-axis is in the way. So I'm going to make the y-axis a lot longer so I can extend these lines for x equals -1 and x equals 1. So you've got to understand that these lines are x equals -2 because everywhere on this line, x is -2. This is a line y equals -8 because everywhere on this line, the y coordinate is -8. So for example, where x equals 4, there's the x equals 4 line. Where it meets the y equals -8 line is the point 4, -8. Now that's not on the graph, so we're not going to label it. But we want to understand that where one of the vertical lines meets one of the horizontal lines, that tells you what the x and y coordinates are. And that's exactly what we mean by the coordinates. It's not exactly the way you saw it in open math, but everybody did fine in plotting points. Okay. First 9 problems, I think, were just plotting single points. When we got to doing graphs, I saw a lot of stuff that I wasn't sure, just wasn't sure where a lot of it came from. Okay. But there looked like some work was done there. Uh, and um, so not all the graphs look like this graph, but most of them that you've completed, if you completed a graph, most of them look just fine. Well, let's see what the completed graph looks like now. When x equals -2, y is -8. We've got our line for x equals -2 and our line for y equals -8. So here's a point on the graph. It's this point, and we could label it -2, -8. Then we have -1, -6, and so forth. Well, where's -6? Well, here's -8. Y is -8 here, and y is 0 here. Halfway between -8 and 0, it's pretty easy to find a halfway point, would be y equals -4. Halfway between -4 and 0 should be y equals -2. And halfway between -4 and 8 is y equals 6. -6. So now I've got a grid. Now, you're also taught to put the labels close to the x-axis and close to the y-axis. Okay? Now, if that's the way you're told to do it, and that's the way your instructor wants to do it in a pre-calculus class, do it that way. I don't like to do that because my labeling is going to get in the way of my graph. Here, the labeling is out away from where this graph is going to be, so the labeling isn't going to interfere with the graph. It also reinforces the fact that x equals something is a vertical line and y equals something is a horizontal line. All right. Now, bottom line, if you marked off 10 points here and 10 points here and put the points in the right location, fine. I'm just showing you the way I kind of prefer to do it. And another thing is, I'm not sure that the half worthless camera has everything. Okay, it's a great camera. I mean, really it is, but It's got a few qualities like it only autofocuses. So you never know if it's in focus or not once you're watching it. Okay, anyhow, it wasn't picking up these labels down at the bottom, but there's the x equals 0 line, which is the y-axis. The x equals 8 line is here. And then halfway there is the x equals 4 line. And then halfway from here to here is the x equals 2 line. Here's the x equals 1 line, and so forth. Okay. -1, -6. Well, here's the x equals -1 line, and we go down here until we hit the y equals 6, -6 line, and there it is. Then when x equals 0, that's the y-axis, we have y equals -4. So we go along the y-axis till we hit the line y equals -4, and there it is. And then we have 1, -2. The x equals 1 line meets the y equals -2 line right here. And the x equals 2 line meets the y equals 0 line. The y equals 0 line is the x-axis. And we've got these points, which appear to lie along a pretty straight line. Okay. Now it's a hand sketch graph, so some of my points are a little bit off. These three seem to be right dead center in the line. This one and this one seem like they're a little high, but you know, my dotted lines weren't perfect. My spacing wasn't perfect. Okay, but another point is, for a straight line graph, you only need 2 points. Okay? Now, your text asked you to do, or Open Math asked you to do a table for 5 points, typically, and fill it in and put the dots on the graph. Okay? You want to also do that by hand. You want to have a notebook. You want to have these things sketched by hand because that's what you're going to have to do in the class. And you have to know how to sketch these. And I think most of you who got as far as the sketch made a pretty good sketch. Okay. I think one person had the line going back this way. But if you did, I think you see how it should have been done. Okay. And once you see it, it's pretty easy for a straight line. Make sense? Okay. Now, what's coming up is we got to deal with equations of straight lines. So let me pause for a second. Okay. So now let's say we have the formula, the function, y equals (3x minus 12). There are 2 questions that we ask of just about any graph. And one of the hardest things I find to do is convince my pre-calculus students that that's important. Let's make sure this thing's in focus because it looked just a little blurry there for a minute. Okay. Okay, so the y-intercept is the point where the graph crosses the y-axis. Now you can see the y-intercept on the graph that we just did. Where's the y-intercept? Well, it's right here. This is where the line crosses the y-axis. It's the point -4, 0. I'm sorry, 0, -4. Okay. X is 0 because X is 0 on the y-axis and y equals -4. So I can say at this point, I almost wrote y. It's a bad looking x, but you can tell it's an x. X equals 0. And there's some smudges there. Let me just make a little better x. Everybody goes blind trying to look at this. X equals 0. Okay, x-intercept. X-intercepts in general, there could be more than one, but for a straight line, there's only going to be one. But x-intercepts in general, at every point where the graph crosses the x-axis. Now, for what we call functions, there's only one point where the graph crosses the y-axis. We'll see that. Okay. But when you're dealing with functions, there are many functions where the graph can cross the x-axis a bunch of times. At each such point, y equals 0. So the y-intercept of y, not abbreviated intercept, y-intercept, int, and I guess the dot over the I should go above the I. Y-intercept of y equals 3x minus t. It occurs when x equals 0. Here's the reasoning process you go through to find a y-intercept. And you want to write that statement out. You don't want to just automatically plug it in so you don't really think about it, because that's what you do. And then you forget it and need it 3 weeks later and have no idea what you did. Okay? So I strongly recommend that you write this out. Okay? And at this stage in the course, I'm also going to really recommend that you have a dedicated notebook for this class. And when I come around, have it open but face down so you're not using it to do your quiz on your desk so I can take a look at it. Not required to do that, but I think you're going to do a lot better if you do. Is there things that I can see, things that I can point out, things that I can address for the whole class that most people are doing? Okay? Should be a dedicated notebook. You need to start keeping your work. And I can see if you're writing out this statement every time, you can abbreviate it. And I'll start abbreviating it. But the first few times, write out the words so you know what things mean. If you keep looking at the words, the idea is going to sink in and stay there. All right? And this is one idea that just does not stay there for students because of the way people are allowed to do their homework in the, you know, in the classes that precede this one. Okay, so if x equals 0, you plug in 0 for x, and you get y equals -12. Again, I recommend you write out all my words until they sink in. Then you can start abbreviating. So there's your reasoning for the y-intercept. We also now have a point on the graph. The y-intercept is at y equals negative 12. So I'm just going to draw a little line here that represents y equals negative 12. And there's my y-intercept. I don't need any other labeling on the graph. That does it. Okay. Now the x-intercept takes a little more work. Here's y equals 0. So here's your graph. Here's your linear function, okay? The equation of your straight line. You let y equals 0 and solve for x. Now we've solved linear equation. That's a really easy one to solve, okay? I just add the equation 12 equals 12. Then I get 12 equals 3x minus 12 plus 12. So, and I put a few dots there. You should really fill in all the details to keep reminding yourself of the rules that you're using when you solve equations, because people lose track of them, okay? So in any case, you're going to get x equals 4 when you solve this equation. So you let y equals 0 and solve whatever equation you get for x. It's a linear equation. It's generally really easy to solve. Okay, so let's put a line here for x equals 4. So right there is a pair of points on the straight line. You know, if I could draw a straight line, boy, that's bad. But there's sort of a straight line that sort of goes through the points, okay? Should have drawn it from here to here. The way to draw a good straight line through 2 points, you got 2 points. You start on this side of this one, and then you look at this one, because if you're looking at it, you're probably going to go through it, okay? If you look at it, then you're aiming at it, and you're much likely to get the point. I was trying to look at this one, and my arm was in the way. I got clumsy with the chalk, and I missed this point, okay? Nevertheless, there it is. Now you could fill in more x and y values. Or you could, in some cases, go ahead and mark off a bunch of equally spaced points. All right? But that's how you find the intercepts. And that's the assignment you're going to have for next time. Okay. Well, for this equation, when you have y equals, it's always as easy as this is. If you have a little more complicated equation, maybe your equation is this. Three x plus 6y equals 24. Make sense? Well, whether it makes sense or not, it's an equation, okay? It's called a linear equation because you just have plain old x, not an x squared, not a 1 over x. And I think we've got a blurry screen again. Please go into focus. It's not listening to me. There it is, but all of a sudden it zoomed way in. I think I've got this camera's replacement right here. Okay. Got to test it out. Haven't had a chance to do that yet. 3x plus 6y equals 24. We want to find the intercepts. If we can find the intercepts, we can get the graph on the equation. Okay. Y-intercept when x equals 0, well, that's going to get us 3 times 0 plus 6y equals 24. That's just 6y equals 24. 6y over 6 equals 24 over 6. Y equals 4. So the y-intercept is at the point x equals 0, y equals 4. That was easy, wasn't it? It generally is easy to let one of your variables equal 0 and solve for the other one. In this case, we've got a very simple equation. And when we find the x-intercept, we're going to get another very simple equation. Now you notice I'm writing a little more abbreviated set of words. After you've written out the full set of words a few times, go ahead and start abbreviating them, something like this, okay? I still have words that indicate the logic. This occurs when x equals 0, okay? That's a statement that tells you something about the y-intercept. So we're going to solve the equation that we get when we plug in x equals 0. And that's going to give us a value of y. So now we have a value of x, which we assume to be 0, and a value of y, which we found to be 4. Now, the x-intercept from y equals 0. I like the word so, because it tells you that the reason we're solving this equation is because that's what the x-intercept is. It's a train of thought that you want to reinforce so you don't have to relearn it before an exam or something. So you don't have to relearn it when you need it to move forward in another course. So we solve and I just said y equals 0, but I didn't substitute 0, okay? So 3x plus 6 times 0 equals, it doesn't equal 0. Let me stop saying profoundly wise words of advice and just write down the equation as it ought to be, okay? When y equals 0, we plug in here, we get 3x plus 6 times 0 equals 24, not 0. Once I got that 0 in my head, I wrote down another one. Okay, makes sense? This matches this with y set equal to 0, and we easily solve this. That gives us 3x equals 24. So, and you fill in the dots, okay? Do the steps. Unless you're sure You got to remember to do them a year from now. Or unless you're so sure of it, you know it's going to come back to you the first time you think about it in September 2028. Okay? So x-intercept is at point where x is 8 and y is 0. Now we can draw the graph. Okay. First of all, 8, 0. X has to be 8. I'll draw the line x equals 8 here and put a point here. And then y equals, well, when y equals 4 and x equals 0, right there is the point 0, 4. And now we can make a line. And this is the graph of 3x plus 6y equals 24. I'm on it. Okay? Make sense? Well, if you do that much, you pretty much do the homework. And I'm going to take another look at the homework and see if there's a little subtlety anywhere I need to warn you about, because I think you can do this. And while I'm taking a look at that, see if you pick this up. Okay, how about let's see you construct a graph for this by finding the intercepts. Let's see you write out the words, preferably to show me that you can do it. Where the heck did I do it? I think I did it on the other side of this board. Anyhow, put the words in it. Explain what you're doing. Okay, so we want to follow the same procedure we followed over here for this function. So we could distribute the two through here before we do anything else and put the equation in simpler form. But I'm just going to directly substitute for x because the x's go away and we get something pretty simple. We get 2 times -5. Well, that's -10. Everybody got the -10, except some people didn't put the negative on it because they copied it as a plus. It's okay if you had a plus here, it's going to change the numbers a little bit, but the steps are still going to be the same, okay? And then what do? Add 10 to both sides. So we add the equation 10 plus 10 equals plus 10, minus 10 plus 10. And remember, I emphasize the desirability. If you do this, write out the equation that you get. Because if you do, you're less likely to do something like add this 10 to this 9, which I still see a lot of. I haven't seen it today. Okay, so I'm pretty happy about that. But this tells you then that 9y equals 46. So 9y over 9 equals 46 over 9. Y equals 46 over 9. Now we got to put that on a graph. So we kind of have to know that that's 5 and 1/9. So the y-intercept for graphing purposes, the mixed number is easier to locate than the improper fraction. It's just a little over 5. Okay, let's do more board space here. And yeah, I can see the whole board. Okay, so x-intercept from y equals 0, so solve 2 times the quantity 3x minus 5 plus 9 times 0 equals 36. Well, we can distribute here. We get 6x minus 10 equals 36. 9 times 0 is 0. This is all we have. So we add 10 to both sides. And we get 6x minus 10 plus 10 equals 36 plus 10, or 6x equals 46. So that 6x over 6 equals 46 over 6. Now that does reduce. That reduces to 23 over 3. And that equals 7 2/3. So the x-intercept is at, I'm going to use the word at, to avoid some ambiguity in the terminology. X-intercept is at 7 2/3, 0. So now we can draw the graph. We need I'm not going to draw a line for x equals 7 2/3. I'm going to draw a line for x equals 8. And 7 2/3 is really close to 8. Just a little bit to the left of 8, we have the x-intercept, which is 7 2/3, 0. We have the y-intercept, which is at 0, 5 1/9. Well, I'm going to draw a line for y equals 6. And if I wanted to, I could divide this in half and get y equals 3. Put a couple of lines in here for 4 and 5. Put a couple more in here for 1 and 2. I'm not going to label those lines, but to help me locate 5 1/9. If this is 5, then 5 1/9 would be about here. So this point would be the y-intercept. I'm really bad about doing that. Write down the first number I think of without focusing on the fact that this is a y-intercept. So there it is. Now, if you made a sign error of some kind, your x-intercept might have ended up on the wrong side of the graph. So check your arithmetic against or your algebra. And that's what I did here. But I pretty much saw everybody doing good steps. But a careless step where you forget to divide both complete sides by 6, let's say, or have a sign error, can lead you astray. And we've got a question, so let's stop and get that. Not sure what I was recording, what it was, but I think I just forgot to hit the record button. Okay. So anyhow, I've just written down the idea that we're looking now at the slope between 2 points. So here's a graph showing 2 points. And we want to find the slope between these 2 points. How do we do that? How many of you remember the words rise and run? How many are familiar with rise divided by run? That's what slope is. It's not a formula. Unless I want to say, well, it's a formula and that happens to be rise over run. Okay? I don't want to talk about the formula before I talk about the idea, which is rise divided by run. The formula embodies the idea. Okay? The formula is not the starting point in understanding what slope means. It's rise divided by run. And anybody, I'm going to give you a minute. And you can just write rise equals run equals, okay? So write that rise equals run equals. Don't take the time to copy everything down. Do that later. And tell me what you think the rise and the run are from this point to this point. Just to see how many of you have the idea, and then we'll explain it and depict it. Okay. So let's see. The run is how far? How far you got to go over to get from this point to this point? Okay. Say the rise is how far up, although sometimes you got to go down, which is a negative up. Okay. We'll see that. That's not hard to understand. So I'm going to draw a path. I'm going to draw a path from this point to this point. Okay, you ready? Watch me draw the path. Okay, so I'm going to start at this point, and I'm going to go over from here to here. Can you show me with your fingers how far I went over? Okay, well, let's see. Some of you got it right, some of you got it wrong, but that's okay because we're going to figure it out now. How far do I have to go over to get from here to here? Get from -4, -3 over to the y-axis. How far do I have to move in the x direction? I had to move 4 units, right? Because I'm going from x equals -4 to x equals 0, right? Got to remember that's a line x equals 0. Of course, we have marks on the graph. You could count them 1, 2, 3, 4. All right. But we just want the idea. If I'm at -4 and want to get to the y-axis, I got to go 4 units. Now I want to go from the y-axis to x equals 6. How many units is that? Show with your fingers. Yeah, well, that's 6 units. You're going from x equals 0 to x equals 6. So we got to go over 4 units and then 6 units. Of course, to get from -4 to 6, we could subtract -4 from 6. Okay? So I can say the run is 6 minus -4, which is the same as 6 plus 4, which is 10. Then what do you think the rise is? Can you show me the finger? It's 8. Okay. You can see that you got to go up 3 to get to the x-axis. From y equals -3 to y equals 0, you got to go 3 units, +3. And then from 0 up to 5, you got to go 5 more. That's 8 units. Now you can actually combine that into one simple calculation. You subtract where you start from where you end. Got a word over here. It's where you end minus where you start. Okay. If you want to know what the displacement is from exit 14 to exit 19, you do 19 minus 14, right? If you want to know what your displacement from 19 to 14 is, you do 14 minus 19, which gives you -5, meaning you're going 5 miles south. Okay. So I will draw the hypotenuse and I write out what the slope is. It's rise divided by run. 8 divided by 10 0.8. Now look at what I've got here. I put a box around this final result for the slope. Okay. And now I can look at this picture and see every part of what I had to calculate to get the slope. I see an arrow that goes horizontally, followed by an arrow that goes vertically. That's a path you could follow from here to here. Now, if this arrow is pointing to the left, I can't follow it. So I can't get from this point to this point by moving to the left, can I? I've got to move to the right and then up. Now, if this point was lower, I'd have to move to the right and then down. And my up would be a negative number. Okay. I recommend we always start at the leftmost point, so the run will always be positive. So we're always going left to right. Not necessary to do that, but it avoids confusion. Okay. Well, that's the idea of slope. Now we'll go on next time with slope intercept form, but you want to kind of review this and make up a few points. Calculate a few of your own slopes just to refresh yourself. Take 5 minutes and do that so that when you come into class, we don't have to stumble over slopes. But I'll do it quickly and give it a little thought.